blocked you on Instagram yesterday. What? I blocked you on Instagram. Oh, yeah.
All right, welcome back, everyone. Hope you guys had a nice break. Let me go over the calendar for the remaining weeks that we have. So we're gonna have we did a trig curve sketching before break, and the other new topics that are in this unit are related rates, which we'll spend 2 days on, today and tomorrow. And then our last set of derivative rules, which are inverse trig derivative rules, we'll practice through those rules and finding those derivatives Wednesday, Thursday. And then we can begin our test review. So your test will cover all the topics that you saw on the quiz, which I pretty much finished grading, just have to enter them into the grade book. I should be able to get those back to you. Those look really good. Plus trig, relay rates, inverse trig, and curve sketching, or curve sketching. So those are the topics on the test. And we'll have 3 days to do test review. So we'll do Friday, Monday, Tuesday test review, and your test will be next Wednesday. I have one more assessment for us after this, and that is a derivative formulas quiz. So this is a quiz that goes over all the derivative rules that we've learned this semester, plus the theorems. So we'll spend 2 days reviewing. The review sheet that you get will be exactly what the quiz will look like. So you're just going to practice the review sheet, and then Monday you'll take the quiz. Everyone should do well on this. If you are not happy with your grade, then I'll let you retake it for full credit one of these days. Okay, so if you don't do well on this, you can retake it for as many times as you like, up to 100. Okay, so you should all do well on. Okay, so those are the remaining grades. Any questions? Okay, in this one, you'll get to use your calculator. Okay, so this is different than this calendar is different than what you see in your packet. So I'll send out a text remind today as well, just to let you know these are the dates for our assessments. All right, let's go to our notes. This will be on page 15. All right, so have you guys copy down the steps for related rates. We're going to review related rates, but with trig, there's something a little bit different, a little bit extra with the steps involved. So we'll go over those in a moment. Okay, so these are the steps involved with related rates. We may not do the steps in this order, but these are all the things that we're going to have to be able to gather before we can find our answer. So we have to be able to list out our known and unknown variables, also identify the variables that are involved in this equation or in this problem. We're going to write a trig equation that relates the variables. So we're either going to use sine, cosine, or tangent, and it's always going to be with a right triangle involved. We're going to find the derivative with respect to time. So this is where our d over dt will show up, dx dt, dy dt, d theta dt. So remember with related rates, each time we find the derivative, we're going to attach a d over dt for that variable. And then last, we're going to use trig ratios to substitute values and solve for the variable. So that step 4 is going to feel a little bit different in terms of we haven't seen problems with this type of step before. So okay. Okay, so here's example 1. Okay, a fish is being reeled in at a rate of 1 foot per second from a point 15 feet above water. At what rate is the angle between the line and the water changing when there's a total of 25 feet of line out? So our right triangle is going to be here. Okay. So let me draw this over here. Okay, so at the top of this triangle is top of the dock where fisherman is here. We have 15 feet of distance between the top of the reel and reel and the water here. So 15 feet here. This is not going to change. As the fish is being reeled in, we know that the z is decreasing over time. And then we can also imagine this theta is getting larger, right? That as we get closer and closer, this theta is going to get larger over time. Okay, so this is what we are starting off with. Anytime we're dealing with related rates with trig, we're always going to have to be able to know where the theta is, and we have to be able to know where two silets, either variables or constants. In this case, we have a constant and a variable, and we're going to be identifying a trig function that's going to hit all 3 of these values. So which is best suited which trig function is best suited for this triangle here? Sine, cosine, or tangent? Sine, yeah. So we are going to do opposite over hypotenuse. So that is going to be our starting equation. So we're going to say sine of theta is equal to 15 over z. Okay, so just like with related rates from previous units, we just have to get it ready for the derivative, find the derivative, and then attach d over dt for each of the variables. So that sine of theta, we can go through the trig derivative in a second. The right side here, though, 15 over z, anytime we have a numerator and denominator and one side is showing a constant, we're going to always try to avoid quotient rule. I mean, it's not wrong if you did quotient rule, but it's just easier to just bring whatever the denominator either in front or to the top so that we're not having to, we just rely on power rule. So in this case, I'm going to rewrite this, avoid quotient rule, bring that z up to the top and make it 15z to the negative 1. We're going to find our derivative. Sine theta. What's sine's derivative? Cosine, right? And then as soon as we find theta's derivative, we're going to have to attach a d over dt for that variable. Right? 15z to the negative 1. We brought that z up to the top. We can avoid quotient rule. We can just rely on power rule. So we go through our derivative. 15z to the negative 1 becomes negative 15z to the negative 2. And don't forget dz over dt. Okay, let me just do a little bit of cleanup, and then we can gather information from the problem again. I just brought that z back down to the denominator here. All right. So we're done with the calculus. Now we should be able to figure out what information can fit into this equation and then solve for our missing variable. Okay, going back to our problem here. A fish is reeled in at a rate of 1 foot per second. Okay, what do you think this value is referring to? Which variable is that referring to? Fish is reeled in at a rate of 1 foot per second. Okay, there's motion involved, right? So it's got to be a time variable. What do you think it is? Yeah. Which one is it? Is it z or is it dz dt? Yeah. Anytime we see a per second motion, increase, decrease, you know it has to be a d over dt. Any adjustment that we need to make with dz dt? What's happening to z as time passes? Yeah. So therefore, this should be what? Negative 1. Okay. So dz dt is negative 1. At what rate is the angle between the line and the water changing? So what do you think we're looking for? Angle between the line and the water. Yeah. Which variable is it, theta or d theta dt? Rate. D theta dt. Yeah. So that's our goal here, d theta dt. So we have negative 1 that we can plug in for dz dt. When there's a total of 25 feet of line out, what's 25 referring to? Z, okay. So look at what we have. We have dz dt that we can plug in. We have z, which is 25. We're looking for d theta dt, which is our missing variable. There's one more thing, though, that we need to figure out. Okay, more than that, we're going to be finding cosine of theta. So I want you to make sure that we understand that we're not looking for theta. We're going to be looking for cosine of theta. We're going to find a full replacement for that trig ratio, or find a trig ratio that replaces that cosine theta. And then we should be able to have everything that we need to find d theta dt. So we're going to keep reminding ourselves that we're not looking for theta. We're going to find a full replacement for cosine of theta. So to do that, we're going to figure out all all the sides of the right triangle at this moment in time. So we're going to draw a separate triangle, and we're going to try to fill out all the sides of this triangle for this moment in time. So we know this is theta, this is 15. Now, at this moment in time, z is 25. And if I have two sides of a right triangle, how can I find that third missing side? Pythagorean theorem, right? So I can say a squared plus b squared equals c squared. We can use our calculator. You can also recognize this as a variation of 3, 4, 5 right triangle. So it ends up being 20. Now we're going to use this to help us find cosine of theta. So now if I step to the side here and look at this triangle, what's the ratio for cosine of theta for this moment in time? 20 over 25, right? Adjacent over hypotenuse. So 20 over 25 can reduce to be 4 over 5. And now this is going to replace the entire cosine of theta. This is where I think some students get stuck on the test. Students tend to get stuck trying to figure out, wait, how do I find theta? And they're trying to find theta and they can't find theta and they get stuck. So remind yourself that you're going to replace the entire trig function, not just theta. Okay, so we should have everything that we need. So we're going to plug everything in now. Cosine theta gets replaced with 4/5. E theta dt is the unknown. Then we have negative 15 over z squared. And then dz dt is negative 1. Okay, so I'm going to bring that 4/5 over, dividing by a fraction, the same thing as multiplying by its reciprocal. Two negatives cancel out. Okay, so let's see what that gives us. To give us 0.03, which you can leave it in that form, or you can convert it to a fraction, 3 over 100. And your units of measure for radians is always going to be, for units of measure for theta is always going to be radians, not degrees. So it's always going to be radians per time unit. And then our time unit is seconds, so radians per second. Okay, any questions? So what's new about this related rates problem is dealing with trig, or dealing with the trig function, a trig ratio, and then finding the derivative, and then making sure that we're going to create a separate triangle so that we can find a ratio for that trig function. So what I highlighted with red is what is new. Okay, this is kind of like the new process within related rates for this type of problem. Okay, we're going to skip number 2. We want to do this type of problem, so let's go to page 16. Okay, so this is the classic ladder problem that we started related rates with when we first learned this topic. So A and B should feel familiar. A and B should feel like it's review. And then part C is where our new process involving theta comes in. So let's set up A with what we know. So if a ladder 50 feet long, being pushed against the wall at a rate of 5 feet per second. So it's getting pushed against the wall. So this is the motion of the ladder. It's going to rise up against the wall, and it's going to get closer towards the wall on the ground. When the bottom, when the bottom of the ladder is 30 feet from the wall, what is the velocity at the top of the ladder? So we know that this is going to be a Pythagorean theorem problem. We can find the derivative with respect to time. Just get the calculus out of the way. Okay, let's list out all the variables. Ladder is 50 feet long, so that's going to be Z. Pushed against the wall at a rate of 5 feet per second. So we know that's dx dt, but any adjustment that we need to make with that 5 feet per second? What's happening to x over time? Decreasing, right? So this should be what? Negative. Okay. When the bottom ladder is 30 feet from the wall, so that's x, what is the velocity at the top of the ladder? So we're looking for dy dt. Pythagorean theorem can help us find y. A squared plus b squared equals c squared. That's a variation of the 3, 4, 5 right triangle. And then dz dt, what's the rate of change of the length of the ladder? 0, right? It's going to stay 50 at the beginning to the end of the problem. So that length is never going to change. Okay, so plug all that information in. Pause at 300, sorry. All right, dy dt being positive should make sense because as the ladder is getting pushed against the wall, it's rising up against the wall. So we can expect that y, the height of this right triangle to be increasing over time. All right, so that's part A. Part B, at what rate is the area of the triangle changing? So we know area is 1/2 base times height. The base and height can be represented as x and y, just to be consistent with what we've built at the beginning of the problem. And then we know this requires what to find the derivative. X and y are being multiplied, so we got to go through what? What rule? Product rule, right? So f prime g plus f g prime. One half x becomes 1/2 dx dt. G stays as y. F stays as 1/2 x. And g prime dy dt. Okay. We can reuse everything from part A since this is talking about the same moment in time. So okay, plug in the calculator. Our units of measure, area is in terms of square feet, times in terms of seconds, so square feet per second. Okay, part C says, at what rate is the angle formed by the ladder and the floor changing at this moment in time? So we know we got to involve sine, cosine, or tangent to build our trig equation. Typically, the strategy here is if there is a constant, we always want to involve that constant. It just allows us to avoid quotient rule. There are problems, though, that where you're forced to have to use quotient rule because maybe all three sides are changing. But in this case, we have a constant, so we want to take advantage of that side. We have more than enough information, so we can use either x and 150, sorry, x and 50 or y and 50. So we have multiple ways to our solution. I think part A, we did sine, so let's just try using cosine just to see some variety in our steps here. So, but if you try to use sine, it'll work the same way. You can also use tangent, but tangent would involve quotient rule. So we're going to try to take advantage of the 50 so that we can use the constant in the problem. So let's try cosine here. Cosine the theta is equal to x over 50. So that's always going to be our starting step with our trig related rates. We're always going to be starting off with some trig equation. Next up, we want to get it ready for power rule. There's no need to bring that 50 up, but that 50 can be pushed out in front. We can make it 1/50th times x, and that way we can just rely on power rule. I mean, we can do power rule here. It just feels more familiar if we have that 1/50th in front. Okay, cosine of theta becomes negative sine. Don't forget d theta dt 1/50th x becomes 1/50th dx dt. Right. Dx dt, we know it was -5. That's from what's given to us. D theta dt, we know that's our goal. That's the unknown that we're looking for. And then the one last set of information is that sine of theta. We're going to keep reminding ourselves that we're not going to find theta. We're trying to replace the entire trig function, trying to find a ratio for that sine of theta. So we're going to step to the side here and build a second triangle with all the sides filled in. So we know that x and y are changing, but at this moment in time that we're talking about, x is 30, y is 40, and z is 50. So therefore, what's sine of theta equal to based off of this triangle? 40 or 50, right? So 4/5, opposite over hypotenuse. Okay, so we should have everything that we need. Now we can just plug everything in and solve for d theta dt. Okay, I'm going to bring that -4/5 over as -5/4 so that we can get that d theta dt by itself. Let's see. (25/200) is 1/8. And our units, theta is always radians, and time is whatever they tell us here. So seconds, so radians per second. Okay, example 4. Okay, numbers are a little bit larger with this example, but we can use our calculator with Pythagorean theorem here. All right, so Here's example 4. A television camera on the ground level is filming the liftoff of a space shuttle that is rising vertically according to S of t equals 50t squared. So this gives us, that S of t gives us the position formula for the heights of this rocket at any moment in time. S is in feet, t is in seconds. Find the rate of change in the angle of elevation. So we're looking for d theta dt of the camera 10 seconds after liftoff. Okay, so we can start off by building our trig equation. Which trig equation will allow us to hit theta, the s, and the 2000? Sine, cosine, or tangent? Tangent, right? So tangent allows us to get to opposite and adjacent. So start off with that. Tangent of theta is equal to s over 2000. Right? Again, we can avoid quotient rule by pulling that 2000 out in front. Okay, derivative. Get the calculus out of the way. So tangent becomes secant squared theta, d theta dt. 1 over 2000 s, we know the coefficient is going to stay. S becomes ds dt. Now, ds dt is basically asking for the velocity, right? Because if s is the position of the shuttle, then ds dt is the velocity. So we know that the velocity is related to the derivative. So out to the side here, we're going to find s prime, which will be our ds dt. So s prime of t is equal to 100t. Just do power rule off of that height formula for our shuttle. And we want to find the velocity at 10 seconds after liftoff. So we'll do s prime of 10, which is 100 times 10, which is 1,000. So this is basically going to be our ds dt. So the variable looks a little bit different, but they mean the same thing. ds dt is the rate of change of the position, which is velocity. Velocity is s prime. So that's the connection there. So we have ds dt that we can plug in. We know we're looking for d theta dt. Now the last piece of information that we need is figuring out what is secant of theta. Remember, we're never solving for theta. We're always trying to find the full trig ratio to replace. So we're going to draw a separate triangle and find all the missing sides. So we can find the ratio that we can replace secant theta with. So we know this is 2000. We need to find the height of the shuttle 10 seconds after liftoff. So we can fill out this side here. So what can we plug 10 into if we want to find the height of the shuttle? Into S of t, right? So there's my height formula. Plug 10 in for t. We know S of 10 is equal to 50 times 10 squared. And that's going to get us to 5,000. Okay, this is not going to be a Pythagorean triple. We have to do Pythagorean theorem here to find that hypotenuse, which we need. A squared plus b squared equals c squared. It's going to be a pretty big number. Ends up being 29 million. So 29. Let's just square root of that. So we're going to leave it in that form because Things will cancel out nicely when we square it, but we know that off of this right triangle, we know secant of theta will be hypotenuse over adjacent. Okay, a lot of big numbers here, but we're just going to plug this in and then make the calculator do all the work for us. So secant of theta, so square root of 29 million over 2,000 squared times d theta dt equals 1 over 2,000, and the ds dt was 1,000. Okay, so to solve for d theta dt, we're going to have to divide all this over. So dividing by a fraction is the same thing as multiplying by the reciprocal. We'll do some cleanup here. So 1,000 over 2,000, I can just make that 1 over 2, less numbers to multiply out. And then if I flip this here, I get 2,000 squared. And then square root of 29 million squared, I know the square root and square will cancel each other out. So I'm just make this 29 million. Okay, we'll make the calculator find this for us here. So I got 0.06895, and if I did math fraction, I can get it all the way down to 0.2 or 29. Now, if it doesn't, sometimes this number doesn't quite get out into a fraction. If that's the case, then you just round it to, or just indicate 3 decimal places and then attach your units. Again, theta is always radians, never degrees, so it's radians per time unit, so seconds. Okay, turn to page 17. So page 17, this is your homework, 38, 39, 40, and 41. It's all in the packet. The key is attached on the following pages. So let's spend about 5 minutes, see if we can get through 38. And then you guys can also check your answer with page 19. So go ahead and let's see how much we can do just to begin our homework problem here. So page 17, let's try 38. Okay, so your homework is to finish up these 4 problems. I'll send out a reminder this afternoon. Okay, come get your phones.